Good morning, everybody. This is second lecture from generating function. Next chapter for mathematical methods in the STYBS here. Last time we saw here what is the generating function for Legendre's polynomial here. We saw three examples from the generating function for Legendre's polynomial here. We have to solve some another example here. Another example is show that n plus 1 pn plus 1 of x is equal to 2n plus 1 of x into pn of x minus n into pn minus 1 of x here. This is show that here. Now this is example from the Legendre's polynomial here. We know what is the generating function for Legendre's polynomial here. It is the solution here. Solution. Now generating function for Legendre's polynomial is g of xt is equal to 1 minus 2xt plus t square raised to minus half is equal to summation of pn of x into t raised to n here. So this is the generating function for Legendre's polynomial here. Now here, how to solve the example here? If there is pn plus 1, pn minus 1 here, then differentiate the generating function with respect to t here. So here, differentiate here. Differentiate the generating function with respect to t here. What we get that we have to see here. So here, this is the we have to differentiate this equation here. We know here the differentiation of this term is n into x raised to n minus 1 here. So it is minus half into 1 minus 2xt plus t square raised to minus 3 by 2 here, minus of minus 1 it becomes 3 by 2 minus 3 by 2 here into d by d sub bracketed term here into here differentiation of minus 2xt is with respect to t is minus 2x and plus it is t square, it is here twice t here. So this is the differentiation of the left hand side here. Now differentiate the right hand side here. It is summation of pn of x into n into t raised to n minus 1 here. So here everywhere n runs from 0 to infinity, n runs from 0 to infinity here. Now next step here. So here this is the 2 gets cancelled, these two gets cancelled, these two here minus sign, here is minus sign here. So it is your x and this minus sign, it is plus t, it is minus t here. So this is the next step here. Now here it is 1 minus 2xt plus t square raised to minus 3 by 2 here. Can you write it this way here? It is 1 minus 2xt plus t square raised to plus 3 by 2 and it is equal to summation of pn of x into n into t raised to n minus 1 where n runs from 0 to infinity. No any change here. We only shift this term to the denominator here. But again we have to make some changes into that here. So it is x minus d is as it is here. Now here it is 1 upon x raised to 3 by 2 here. Can we write this way here? X raised to minus half upon x raised to 1. Both are same here. So similarly, we have right here, we have to shift x raised to minus half to the numerator here. So here this is the example here. So we can write here 1 minus 2xt plus t square raised to minus half and remaining 1 minus 2xt plus t square raised to 1. It is same here. And right hand side is same summation of pn of x into n into t raised to n minus 1 here. Here n runs from 0 to infinity here. So now the numerator term, this term to the left hand side here. What is this here? This is the generating function for Legendre's polynomial here. It is summation of pn of x t raised to n here. So we have write this term as a, it is the generating function here. So it is x minus t into summation of pn of x into t raised to n here. And this denominator that we have to transfer to the right hand side here. And what we get here? It is 1 minus 2xt plus t square into summation of pn of x into n into t raised to n minus 1 here. Now this is the another step here. Now multiply here. Multiply the bracketed term with the this pn of x into t raised to n. What we get here? X into summation of pn of x into t raised to n plus. Now here is the minus sign here. It is negative sign here. Minus. Now here is t raised to n. So we get here t raised to n plus 1 here. So minus summation of pn of x into t raised to n plus 1 and it is right hand side here. It is 1 multiplied by this term remains as it is here. It is summation of pn of x into, so take n outside the bracket, n into pn of x into t raised to n minus 1 minus it is twice x. So here I get twice it is twice x into n into summation of pn of x into here is t. Here is t raised to n minus 1 here. It becomes here t raised to n. So here it is minus twice x. It is n is as it is here. Summation of pn of x. It is summation of pn of x here. And here is t raised to n minus 1. Become t raised to n only here plus. Now multiply t square by bracket here n into summation of Pn of x into t raised to here t raised to 2 t raised to n minus 1 here, it becomes here n plus 1 here. Now this is the next term here. So here now this is the term here. Now remember here, now compare the all coefficient, compare with t raised to n here. What we get here, t raised to n, this term remains as it is here. So we get here x into Pn of x here. If there is n, t raised to n, write this term as it is here. Here is t raised to n plus 1 here. So what we have to write here? Here we write here subtract 1 here, Pn minus 1 of x here, minus Pn minus 1 of x here. Now this term okay here, and right hand side here is equal to, here is t raised to n minus 1 here. It is n minus 1 here. So if there is n, we have to write here n plus 1 here. So n plus 1 p n plus 1 of x here, p n plus 1 of x. Compare the coefficient with t raised to n here. So here then it is your t raised to n. There is no any change here. It is 2 xn plus minus twice n into x into Pn of x here. Pn of x here. Now remaining term this here. Here is n plus 1. Here we have written here n minus 1 here. Plus n minus 1 Pn minus 1 of x here. Now this is the another term here. So see here, observe the equation here. Now here is the Pn minus 1 term. Here is the Pn minus 1 term here. What is the answer here? Observe the answer here. That we have to show this here. Now this term is this term here. So what we have to write here? Write this term as it is here. N plus 1 Pn plus 1 of x here. Okay. So here we have to transfer all to the left hand side here. It will be to the left hand side, and we have to write the answer to the right hand side here. But here as it is, take it easy here. So here this term is as it is here, and we have to transfer all terms to the left hand side here. So here is n into Pn of x here. Here is, so we have to write here x into Pn of x. Okay, this term is as it is, we have taken here. What is Pn of x term here? This is the Pn of x term here. That we have to write, take to the left hand side here. Plus 2nx Pn of x here. Okay, remaining term here, it is minus Pn minus 1 of x, and here we have to take here minus n minus 1 into Pn minus 1 of x here, and is equal to this here. So remember here, it is x into, here is x into Pn of x, x into Pn of x, take common here, we get here x into Pn of x, remaining here 1 plus 2n, it is correct here, or 2n plus 1 here. Now remaining here minus Pn1 minus 1 here, so take common minus Pn minus 1 of x here. What is the bracketed term here? 1 minus n plus 1. Okay, so here this 1 gets cancelled. This right hand side is n plus 1, Pn plus 1 of x. It is as it is here. So this term becomes plus here. So we can write here x into Pn of x into 2n plus 1. 2n plus 1, we are writing this form here. 2n plus 1 into x into Pn of x here. There is no any problem. So minus 1, minus here, minus plus p, here is n into Pn minus 1, and it is equal to n plus 1 Pn plus 1 of x here. So this is the example here, or rewrite the term here. What we get here? N plus 1 Pn plus 1 of x. Write the same equation here, is equal to 2n plus 1 x into Pn of x minus n into Pn minus 1 of x here. So this is the solution here. So rewriting the term here, we get the same equation here. But remember here, if there is Pn plus 1, Pn minus 1, differentiate the generating function with respect to t here, and we get the result here. So this is the, and we write here, hence the proof. Hence the proof here. You get the full marks here. So here, this is the another example from the generating function for Legendre polynomial here. So another type of example that we have to take here. So I think it is the last example from the generating function for Legendre polynomial here. So here this is the another type of example here. The example is, show that show that P n plus 1 dash of x plus p dash n minus 1 of x is equal to twice x p n dash of x plus p n of x. Remember one thing here. If in a question paper here, see the question paper. What is the example here? Write the example properly here. Instead of pn plus 1, if you write pn, then if you solve any example here up to the last point here, you don't get the result here. So observe this example. What is the given here? Pn plus 1 dash of x plus pn minus 1 dash of x is equal to 2x pn dash of x plus pn of x here. So here this is the example here from the generating function for Legendre's polynomial here. So what we get here? So we know that here we have to show this here. We know generating function for Legendre's polynomial is equal to 1 minus 2xt plus t square raised to minus half, and it is equal to summation of pn of x into t raised to here. So this is the generating function for Legendre's polynomial here. Now last one I told you that here, if there is pn minus 1, pn plus 1, then differentiate the generating function with respect to t here. If it is dash here, pn plus 1 dash, if there is dash, then differentiate the generating function with respect to x here. So differentiate the generating function with respect to x. So differentiate the generating function with respect to x here. So what we get, that we have to see here. So remember here. So here it is x raised to n into x raised to n minus 1. So remember, differentiate this equation. It is minus half n into 1 minus 2xt plus t square raised to minus 3 by 2 n into x raised to n minus 1 into d by dx also with respect to x. So it is 1 0, this is t square 0, remaining only minus twice t. Differentiate with respect to x. So remaining here it is minus 2x here, and it is equal to summation of with respect to pn dash of x into t raised to n with respect to x. This is the another step here. So here this minus gets cancelled, this 2 gets cancelled, remaining plus t here. So t into, so here t into, this is the bracket term here. As in the last example here, this is 1 minus 3xt plus t square raised to minus 3 by 2 here. If we take in this, can we write in this way here? It is 1 upon 1 minus 2xt plus t square raised to plus 3 by 2, and right hand side same, summation of n runs from 0 to infinity here, pn dash of x into t raised to n here. So here this is the answer here. So can we split this term as t into 1 minus 2xt plus t square raised to minus half and divided by 1 minus 2xt plus t square raised to 1 here. So as last time I told you here, 1 upon x raised to 3 by 2 can be written as x raised to minus half upon x raised to n. Both are the same here. Similarly, we can write here, it is 1 minus 3xt plus t square raised to minus half and divided by 1 minus 2xt plus t square raised to 1. Raised to 1 means it is same here. Right hand side same. Summation of pn dash of x into t raised to n here. What is the numerator term here? This term is nothing but the generating function here. So we have written here. So t into summation of pn of x, summation of pn of x, t raised to n. This is the generating function here. We have to transfer this to the right hand side, is equal to 1 minus 2xt plus t square and into summation of pn dash of x into t raised to n here. So here this is the left hand side, this is the right hand side here. So what we have to write here, we have, it is multiplied by t raised to n here. So how do we get here? Pn of x t raised to n plus 1 is equal to pn dash of x t raised to n minus 2x pn dash of x t raised to n plus 1 here. Here is a t raised to n plus 1 here. So plus pn dash of x t raised to n plus 2 here. So this is the next term here. So here compare the coefficient of comparing the coefficient of t raised to n here. So what we get here? In this case here t raised to n plus 1. Here we have right here pn minus 1 of x here. So it is pn minus 1 of x is equal to pn dash of x. Okay, here is t raised to n plus 1 here. So instead of that, what we have to write here? N minus 1 here minus twice x pn minus 1 dash of x here plus here is n plus 2 here. Here what we have to write here pn dash p dash n minus 2 of x here. So that we have to rewrite the term here. then we have to show that here, this equation here. So what do we get here? We get here p n minus 1 of x is equal to p n dash of x minus 2x p n minus 1 of x plus p n minus 2 of x here. So what is the result here? We have to show that this we have to show here. The result is not same here. Then what we have to do here? Now after the equation here, remember here, if there is Pn minus 1 term, there is no Pn minus 1 term here, there is Pn plus 1, Pn minus 1 term here. If there is, so here in this way here, it is Pn minus 1 term here. So here what we have to do here, replace n by n plus 1 here. So replace n by n plus 1 here. So it is Pn minus 1 x term here. So it is Pn term here. So observe that here and take the decision here. Now here it is only the Pn minus 1 term here and it is Pn of x here. So replace n by n minus 1. What we get here, that we have written here. So it is Pn of x is equal to Pn minus 1 dash. So here replace n by n plus 1 here, we get Pn of x. Instead of this here we get here Pn of x, Pn plus 1 of x minus twice x, P dash n of x plus Pn1 minus dash of x here. So by replacing n to n plus 1 here, we get the result here. So after the example here, so here this is the example here. So here it is Pn plus 1 dash x here, Pn plus 1 dash x. So here keep it as it is here, Pn plus 1 dash of x here plus Pn minus 1 dash of x here. So this term, this is here. So take as it is here. So Pn minus 1 dash of x, it is as it is here, and transfer all terms to the left hand side here. This term is already to the left hand side here. It is Pn of x here. Now remove this term to the transfer to the left hand side. What do we get here? Plus 2x into Pn dash of x here. So what we get here? We get the result here. Or if you want to write in the same pattern here, write this in this way here. So Pn plus 1 dash of x plus Pn minus 1 dash of x is equal to twice x. It is twice x Pn dash of x plus Pn of x here. So here this is the proof of the given equation here. Right here, here is the proof here. Here is the proof here. So here this is the example from the Legendre's polynomial here. Now this is the another type of example here. Now the difference between that here is this p dash, pn dash, pn minus 1 dash and so on here. Differentiate the generating equation with respect to x here. Now this is only change in that here. So here we saw in all 5 examples from the generating equation for Legendre's polynomial here. Today we have to introduce about the generating equation for Hermite's polynomial here. So here this is the another is generating equation for Hermite's polynomial here. So here just we have to introduce about that here. What is the generating equation for Hermite's polynomial here? The generating equation for Hermite's polynomial can be given as g of xt is equal to e raised to 2xt minus t square is equal to summation of hn of x here into t raised to n upon n factorial here, where n was from 0 to infinity here. This is the generating equation for Hermite's polynomial here. Then we have to solve here. We have to find out what are the polynomials here. Now here this is suppose here it is equation. So here we are writing the another way here. So it is here n is equal to summation of hn of x into t raised to n upon n factorial. So it is equation number 1 and it is equation number 2 here. So here take the recall the equation 1 here. So what is equation 1? G of xt is equal to e raised to 2xt minus t square here. Now expand this here. So e raised to something we know that here 1 plus 2xt minus t square upon 1 factorial plus 2xt minus t square bracket square upon 2 factorial plus that here. So leave the higher power of t here. So we have to write in this way here. So here calculate the coefficient of t square and so on here. So first we have to expand this bracket here. So 1 plus 2xt minus t square. So minus t square, it is 1 factorial, it is same here, no change. It is plus 4x square t square minus 4x t cube plus t raised to 4 upon 2 factorial plus that addition. Actually, we don't require the t raised to 3 term, t raised to 4 term here. Only first we have to see only we have to see the t raised to square t square terms here. So connect. So it is 1 plus 2xt. Here is minus t square and here is plus 4x square t square upon 2 factorial here. Plus that is leave the t raised to 3 term, t raised to 4 term, t raised to 5 term here. So it is 1 factorial here. So what we have to do here? Here we have to make some changes here. Here multiplied and divided by 2 here. Multiplied and divided by 2 here. So 1 factorial into 2, it is nothing but the 2 factorial here. So we can replace by 2 factorial here. So here it is 1 minus 2xt. See here minus 2. Okay. Plus 4x square upon 2 factorial into t square. It is correct here. So here t square upon 2 factorial can be taken common outside the bracket here. Remaining minus 2 plus 4x square here. So plus dash here. So we can write here 1 minus 2xt plus 2 into 2x square minus 1 into t square upon 2 factorial plus dash here. So this is the next example, next term here. So then it is, suppose it is equation number 3 here. So it is equation number 3 here. Now recalling equation number 2 here. So what is this here? Here n runs from 0 to infinity here. So this becomes g of xt is equal to h0 of x plus h1 of x into t upon 1 factorial plus h2 of x into t square upon 2 factorial plus dash here. Now it is equation number 4 here. So compare equation number 3 and 4. What we need here? h0 of x is equal to 1 e raised to plus 2xt. So I think it is the plus 2xt. It is 2xt plus 2xt here. So here h0 of x is equal to 1, h1 of x is equal to 2x, h3 of x is equal to 2 into 2x square minus 1. So here these are the Hermite's polynomial here. So we find out the Hermite's polynomial here. These are the Hermite's polynomial here. Now similar to the genetic function for Legendre's polynomial here, we have to solve 3 to 4 examples from the genetic function for the Hermite's polynomial here. Till have a good day. Best of luck.